Hello, everyone, and welcome to episode 3 of our new series called Software Package Deconstruction, Assessing Risks to Your Software Supply Chain. Each episode, we deconstruct a software package and do a deep dive into its risk profile to better understand its unique attack vector. And we hope that in some small way, we can enable your security team to stay one step ahead of malicious actors. Next slide, please. Let's start with a little housekeeping. If you have any questions or comments, please submit them through the Q&A feature on Zoom webinar. We are recording this episode for those who can't attend live, and you'll be able to find it on our website's media pages shortly after the conclusion of today's webinar. After the webinar, we'll also be sending out a follow-up email to all registrants with any relevant links we think you might find useful, as well as a link to the aforementioned recording. And finally, if you like subtitles, click the live transcript button to enable Zoom's closed captioning feature. Next slide, please. Okay, protecting organizations from increasingly sophisticated cyber threats is what we do. At ReversingLabs, we leverage the world's largest threat intelligence repository to protect software development and power advanced security solutions. Our threat intelligence repository is 7 times bigger than VirusTotals, and it keeps the most advanced cybersecurity organizations and Fortune 500 enterprises informed and ahead of malicious actors. Our software supply chain security and threat intelligence solutions have become essential tools for advancing enterprise cybersecurity maturity globally. Our operations are spread throughout the US and Europe, with offices in Zagreb, Croatia, and Cambridge, Massachusetts, with customers reaching every corner of the globe. We have just under 300 employees, and we're looking to hire more. So if you or someone you know is in the market for a new opportunity, please check out our careers page to view our current openings. Next slide. The man who will be deconstructing these software packages for you is Tim Stahl, a seasoned security professional with almost 20 years of experience in information security and with additional experience in information technology related to both the engineering and administration of enterprise networks. Tim has secured and defended networks across .mil, .gov, and .com enterprise domains, and his expertise includes the tracking of both APT and criminal groups, threat intelligence, threat hunting, data analysis, OSINT research, DevOps, and SIM engineering. Next slide. The subject of today's software package deconstruction is UPS Ship Manager, which was chosen to serve as an example of the real-world risk from expired code signing certificates in a software package. Tim's deconstruction will focus on how to detect, investigate, and assess file rot from both a software production and third-party risk management use case. Next slide. The tool we'll be using to analyze UPS Ship Manager is the software supply chain security platform from ReversingLabs. The SSCS platform decomposes the final deployment software image. It describes its underlying software behaviors to determine deployment risks, and when it finds a red flag, it prioritizes remediation guidance. SSCS is powered by the world's largest private file reputation repository with over 10 billion files and about 8 million new files added daily. It not only helps prevent threats from reaching production, but can also find exposed secrets before release. And as a bonus, it can also generate a complete SBOM. And with that, let's turn it over to Tim to begin his deconstruction.
Hi, everyone. Thanks for joining us today. We're going to talk about the theme of this is file rot. Thank you. So like Guy mentioned, this can be tied back to expired code signing certificates, right? But the problem is much deeper than that. So we're going to tell a handful of different storylines to sort of illustrate that and the impact. I think this is something that isn't talked about a lot. And I don't think there's a lot of awareness around this, but this is a significant issue in software production. So we're using the UPS Ship Manager, right? So this is the front end for their shipment service. Um, free application, print labels, ship packages, do all of that stuff. It's a pretty rich and robust application. So we can see here, it's almost 800 megs, 1,300 components. So the reason we chose this is it has all of the elements I need to tell this a comprehensive story around file rot. And that's really the only reason. We're not picking on UPS or any of this other stuff. It just, this is a good foundational package to teach file rot from. So again, we see that there are a relatively high number of issues here, right? Which shouldn't scare people off, right? When you're doing supply chain security, there are, just like any other area of security, there are a lot of patterns that you'll notice over time. This is a discussion of one of those patterns, which is file rot. So this is actually not too bad for a file of this size and complexity, but when you see these numbers and we see a lot of this stuff, generally what it ties back to is missing mitigations. So let's look at the issues tab here and we'll see all the different issues that are part of this package. And you can see the majority of the numbers are in missing mitigations, right? This is a good indication that you have extensive file rot within a package. So if we look at the mitigations that are missing, we have a bunch here, right? And this is how you get to those large numbers, right? Is we have a missing mitigation here. It's in 130 files, right? We have another one, ASLR is in a bunch, but as you go down, and this is just the high priority issues here, right? We have a lot of mediums and the ASLR shows up again. These are pretty common things we see, DEP, ASLR, CFG, those kind of things. They show up a lot. And this accounts for a lot of those issues. So DEP, if you're not familiar, is a memory space security feature, right? This, in the context of file rot, it's significant because this was first rolled out in Windows XP. That's how old this mitigation is, right? And that's part of the issues with file rot is these old files are a snapshot in time. They're the best practices that were in place, 10, 12, 15 years ago. So when you have those files that are that old, they're missing all of these basic things. ASLR is address space layout randomization, right? Where every time you open up the application, that information and the data can be held in memory in different places. It's a moving target for attackers. They can't hit the same place all the time. This was rolled out in Windows Vista. So again, when these things are missing, it tells you have these old files, or there's just poor build practices, right? Another component to this, of the file rot, is build quality. How much craftsmanship and care is going into these packages, whether it's shipped and you're running on your network. These indications show you that some of this stuff isn't being noticed, it isn't being cared for. So this is part of TPRM, and a lot of those things will tell you how much you can trust a vendor or a particular product when you see these things over and over. It's part of that assessment. It gives you a peek behind the curtain, which is really, really valuable if it's not your stuff. CFG is another one we see a lot. That's related to DEP. It's memory protection. That was rolled out in Windows 8. Right. So you really shouldn't be seeing a lot of these missing things. These are pretty standard now. So when you do see these things missing, it's going to be based on old files. So let's look at the prime indicator of this, right? So code signing certificates, when they're expired in here, we're not saying that, Microsoft is using an old certificate to sign new files. That's not how this works. What happens is this file was signed by a certificate that expired 16 years ago, which means the files themselves are older than that, usually a year or two, right? Code signing certs are usually good for a couple of years, but that gives you a good indication, right? So you have a file here that's 22 years old. Let's open it up and see how many. All right, there's a couple. And we see this a lot as well, where you see the same file in different places. And this is, again, how you get those big numbers is now each of these files has 8 issues. Now they're in different places, and at least one of them is a critical issue. P0 is critical. P1 would be high, and it goes down from there. But so you have critical issues in 4 different places. Walking through some of this.
Yeah, I'm curious. File rot seems to be a software producer issue. So
Hmm,
What is the benefit of surfacing this issue if it's not in your code?
good. Yeah, that's a good question. So really, really, this whole focus is on TPRM, but it is a producer issue. It's mostly of awareness, right? We're going to explain, we have a couple of different storylines in this, and we're going to show you examples of why that impacts you as a software consumer, why having this on your network may be an issue, or why seeing this common element or this lack of care in the production of software on different lines from the same vendor may tell you maybe I can't trust that vendor, or maybe I don't want this product. This is also great when you're buying software or for M&A activity, really, because in M&A, what you're really buying is the whole production system. And this gives you an indication of how much you're going to have to invest to get that modernized and up to date. So these inform you that you may have these hidden things. And I'll give you several examples, and we'll talk a little bit about that at the end too. So thank you for bringing that up, Guy. Yeah, and as we go through this, you'll start seeing, right? We see this a ton. There's also a little bit of a misconception or definition mismatch when you're talking about supply chain security. A lot of tools will talk about open source, right? Open source, open source. That's great. But open source is only one component of third party applications. And really, we see this a ton as you'll see tons of Microsoft stuff, Microsoft DLLs. Yep. Older these things. And again, they just work. So people just keep using them. And we'll see a lot of third party components and open source components that follow the same pattern. Whereas as long as it keeps working, as long as it keeps producing, nobody bothers to go look it up, find the issue, and then update it. Because really, you can really wipe out a lot of issues by just simply updating some of these packages because they tend to be in clusters, right? So, there's some Microsoft stuff, some VeriSign with component one. So these are generally not files. They're part of a component, a larger component. Also keep in mind that not all software elements are signed, right? There are 1,300 different software components in here, but not all of them are going to be signed. This is a subset of that, but this gives you an indication that it's going to be a broader problem because these issues will also be found in packages that aren't signed or components that aren't signed in here. So you see a lot of different vendors, and you can see that it's weighted, towards the older end. So there's 22-year-old, this is one file in 4 different places, right? It's not so bad, but you'll see, larger numbers in some of these, and that just increases the issues that they bring to the table, right? 140 files for this one. So all these different vendors show up, and you can sometimes tie these back to specific packages, right? And I've done that for some of these things. So looking at this and knowing that in this package, there are 46 code signing certificates in use, 44 of them are expired. Now, that's common. If it's expired, like down here, we see that it recently expired components or a year or 2 or 3, those aren't as bad, right? You will start to see them pick up some CVEs as they age out. But when you hit some of these older ones, you have more issues that come into play here. So if we look at the bill of materials now, right, we know that there's some Microsoft stuff that's expired, some UPS stuff, their own, packages or their own components are older and not being updated. So we'll look at the bill of materials, and this is everything, right? So this is signed, unsigned, whatever. This is all of the software components we found. So again, going through this, you'll see the product names and the different things that are in here. And sometimes you can tie them back to the signed code. Sometimes you can't, but the issues are still the same. So we look at this WASP bar, right? There's multiple different files. These are all part of one package, WASP bar, whatever that ends up being. But there are 8 issues for this file. And you can see from the file path, sometimes it gives you an indication of where it gets put. This whole thing is 12 years old. So again, this is where we see, all right, this whole piece of code, all these different elements are part of a package or a subcomponent of this software. WASP bar is just added in, but it's never updated. So this being 12 years old, there has to be another update, but this won't get cared for unless it breaks. And this is part of that file rot, is this happens over and over and over in almost every software you use, because if it's not broke, it doesn't get fixed. So
And
you
what are
can
those
see,
zebra files there?
oh, Zebra. Yeah. Yeah, I actually had to look that one up. That's the first time I've ever seen this, which that actually is helpful because that is an interesting story that maybe, maybe just I find interesting, but um, this is part of an illustration. This shows you how functionality in software production is prioritized above security vastly. Like it's not even close, right? Security generally tends to be an afterthought. You know, they do, public sentiment drives different things and they'll implement different best practices, which is great. But some of these things don't get picked up. So Zebra is actually, these are print drivers, right? This software is meant for helping you ship, right? So one of the things it can do is print labels. Now, if you think of this from the producer's, mindset, they don't know what OS their customers are running, what version of Windows, what updates, what security features may be enabled, blah, blah, blah. There's so many different things. Every different customer is going to have a different set of circumstances. That makes it really hard to write this kind of code that just works. One way around that is you ship your own drivers for your printers. So now they control everything and they know which drivers are going to be in use. It helps stabilize their code. But these never get updated, right? So these print drivers, again, are over a decade old. But when you install this software, it forces you to use these drivers and not the drivers that are local. So this is the kind of decision that gets made to save time, effort, and resources on pushing this out. And it improves stability, but at the cost of security, right? So again, this file rot will highlight some of these issues and you'll see these types of things a lot, especially in this type of product. I would say that, while we're not picking on UPS, this segment of software is one that should be of higher concern to folks, right? Where this is sort of the free downloadable piece that ties you to a back-end service. The time, the effort, the resources are all put into securing the service itself. This is just the doorway to that service, right? So as long as they're maintaining standards, data is encrypted to and from, that kind of stuff, they're safe. But there's not as much resources and effort put towards this piece as there are to the main core, securing the main service in the cloud, right? And that's true of any kind of thing where you download an application and it's the gateway to a service. You're going to see more of these types of issues in that type of software. And that's also the kind of software that's all over your network because you need these specific things to get certain things done. So package management is just one example, but there's a lot of this kind of stuff. Should be a concern. You should be aware of this at least, right? Is that these have a higher instance of file rot and a bunch of other issues. So, for TPRM and, protecting a network as a software consumer, just keep that in mind. So we have, WebBar, we have Zebra. There's a lot of different things in here and we'll see, right? They have multiple issues. Each one of these has multiple issues, right? So these are older. Again, the Zebra ones are older and these also have some CVEs. Right. We'll touch on that in a second. We'll talk specifically about the CVEs here and how that relates to file rot as well. So we did signatures and we did the bill of materials. So now you can sort of get a sense of how these things pile up and why you see these large numbers and how they pile up in the mitigations, right? As the files age, that's all they do is pick up more best practices that they're missing, more mitigations that, are best practices now that weren't 10 years ago. So these just age and pile up CVEs and issues over time. But as we saw in the signatures page, right, it's not uncommon to see 7, 8, 10-year-old components in these packages. I would bet you see that at least half the time. This is not the first time we've seen a 22-year-old code signing certificate in a package. So if we go to the bill of materials, again, this gives you a breakdown of everything. So going one step further, and let's look at the CVEs now. Let's go down here and see what we have. All right, so there's a decent list of CVEs. And let's look at what they're impacted, right? So this is a good trick I like. So we'll look at the source of these CVEs and look at the source, libcurl, right? This is a graphics engine, displays TIFFs, OpenSSL for network communication, and zlib for packing and unpacking. None of these elements are part of the code for this package. These are all third-party components. Well, while they're third-party components and they have CVEs, the reason is these are actually dependencies. So these are third-party components that are dependencies of those old, aging, rotten files. So a file that's old like that also brings with it its old dependencies, multiplying the issue, right? So again, these grow exponentially, and this is why, seeing this the expired certificates, and a lot of them and really old, is always going to lead you to this, because to function, those old files need the old dependencies. They drag all of that stuff with you, and that all gets installed on your host or your network. Um, Even worse, well, let's filter by exploit exists, because these are the actionable ones. These are the ones you have to be worried about. And still, you have 14 vulnerabilities that exist, and they appear in zlib, right? These are old versions, right? So this sort of, hopefully this illustrates the way this impacts you. And it seems like such a trivial thing. Well, there's old files, sure, but this is sort of the impact, right? Is these old drivers, these old elements, and then all the things they drag with them to poison your network. This is a serious issue, and it's something that should be at least, I'd like this at least see some more awareness around this. This is something you should be aware of, and start paying attention to what types of files on your network have these kind of things. And I think you'll see that it'll cluster in certain areas, like we said, the free applications that tie to a service. Anything that's a gateway to a service is generally not as important to the manufacturer as the service itself. So we have a lot of issues here. And they all sort of tie to the same thing. It's all tied to file rot, right? So I think that's most of what I have for the demo guy. Hopefully that illustrates the point. I don't know if we have any questions. Please feel free.
Yeah, let's switch back over to the slide deck. There does not appear to be any questions, but please feel free to submit any through the Q&A function. And okay, I guess we'll just go ahead and move on to the next slide. Yeah, so for those of you interested in analyzing your own software supply chain's security profile, we've got a 14-day free trial available to you of the same software that Tim just used to analyze UPS Ship Manager. And we'll pop its link into the chat right now. There's no credit card required or software to install. Just create an account and you'll get 14 days of free access to a full-blown version of our software supply chain security platform. You can use it to analyze malware and code tampering embedded in your software components, or generate an SBOM listing all the open source and third-party packages and software you're using, or leverage the platform to contextualize and prioritize alerts and threats in your software supply chain. Again, there's no charge, so please take advantage of this risk-free trial. And I guess we don't have that into the chat yet, so let me put it in there myself. 1 second. Okay, everybody should have that now. All right, and next slide, please. Okay, be sure to join us for our next episode of Software Package Deconstruction, when we're going to take a look at crypto wallets. The decentralized nature of crypto wallets have made them ripe targets for threat actors. But what if there's a bigger threat from within? We'll explore the nature of performing third-party risk management to evaluate the build quality of a crypto wallet software package, as well as explore the quality of several common crypto wallets to evaluate their risk profiles and threats to their users. By the way, this topic is very timely because just this past Saturday, users of Atomic Wallet might have fallen victim to Lazarus, the infamous North Korean hacking group, according to blockchain intelligence firm Elliptic. On Saturday morning, the team behind Atomic, a non-custodial crypto wallet, announced that some users were compromised and lost funds from their wallets. Tim, you might have a bit of insight to share on that, I believe.
Yeah, it wasn't that fortuitous, Wes. We were already working on this, already going through the packages when that happened. So, great for us that it actually ties into this episode as well, right? Like we talked about, these old files, these ancient files also use old, best practices. One of those old best practices, or one of those things that ages over time, are cryptographic functions, right? Where in XP, they were, the functions they use now for cryptography were fine back then. But as computing power grows and advances, they're easier to crack. So old files tend to have old cryptographic functions in them and are easier to attack. So this is similar to what what we see here is it was a weak cryptography that got cracked. So we'll talk a little bit about that in the next version, but we'll go through several different wallets. We'll compare that whole segment of software. I think it'll be interesting.
All right. So, for those of you interested in cryptocurrency security, our next episode is one you won't want to miss, and it airs on Thursday, June 22nd. And we look forward to you joining us then. Last slide, please, Tim. Concludes this episode of Software Package Deconstruction. Thank you all again for attending. Please be on the lookout for announcements about future episodes from Reversing Labs. Have a great rest of the day, everyone, as well as a great rest of the week. And remember to broaden your view of software risk by securing your entire software supply chain.